class. If you go into your test, you can see the correct answers and your answers now with the grade. So let's take a few minutes to go over the answers. You might want to jot some notes down or make some mental notes for corrections, because if you want to retake your test, you need to do test corrections. Very simple, because there weren't that very many problems on the test. Submit your test corrections, and the test retest is going to be on Thursday, May 6th during advisor. So this is coming up on Thursday or Friday during Libo time. One of those two times will be retest time. You don't need to sign up for either of those times. You just show up in one of those times if you want to retake it, as long as you've turned in your test corrections. Make sure you follow the directions in the test corrections. Other announcements are just remember exemptions. You can exempt every class as long as you're passing for this semester, but just make sure that you don't have more than 3 absences, unexcused absences, I should say. Actually, that's regular absences to exempt. If you're virtual, just make sure that you continue to either watch lessons or attend to Zoom or turn in your work on time in order to be eligible for exemption. Okay. Anybody have any questions on that? All right, let's go over the answers to the test so that you can start doing your test corrections if you want to retake the test for a higher grade. On the first section, this section was the matching section. Every one of these examples we did in class at some point, with exception of one of them. Each of these was an example of one of the different functions that we went over through during this unit. So the first one is the relationship between time and the temperature of a cup of coffee as it cools. This one is the negative exponential function. The temperature of the coffee is super, super hot. As it gets cooler, it starts to get drastically colder, but eventually it's only going to get as low as the room temperature. It'll never get below the room temperature unless you actually have some type of you put in the fridge or something like that. So that is a negative exponential function for that one. The next one, the relationship between the number of days since the coronavirus outbreak and the number of infected people after the vaccine has been widely available. This is a logistic function. As we know, the coronavirus broke out exponentially, but eventually, once the vaccine is available, it's going to start to level off. New infections are going to start to level off. So we won't have very hopefully, as we start to approach herd immunity, as long as people are getting vaccinated. When students go on a field trip, each bus holds only 44 students. Even if 45 students go on the trip, 2 buses will need to be taken. So we can only have 1 bus for up to 44. If we end up having 45 students, we get 2 buses. We can't have 2.5 buses. If we got the next step would go up to 3 buses. This is an example of a step function. That's really the only one that we didn't really talk about, but we talked about. You did step functions in the example in one of the homeworks, which a lot of you guys didn't do, and it cost you a couple problems on this test. The relationship between the amount of hours you work in a week and the amount of money you make, the more hours you work, the more money you make, and that's just going to continue linearly. That's a positive linear function. The relationship between your time on a moving Ferris wheel and your distance off the ground, and that is a sine function. We did that exact one in class. You go up, come back down, go up, come back down on a Ferris wheel, which means the last one is a positive exponential function, the rapid growth of the bacteria that is tripling in size every day and no antibiotics to stop its growth. That is going to be growing exponentially. So there are the correct answers for question 1. You should be able to see those correct answers already in case you want to do your test corrections. Question number 2 is not in, the correct answer is not in there, so you'll have to pay attention to the correct part right here. This answer was, I think, 70-something% correct. Most of you guys got it right, or some of you got partial credit. The graph, 2 points, it's 6 points total, 2 points for each part. Make sure that you had to have, it is mostly strong or fairly strong, negative, and it's a linear correlation. A lot of people put, not a lot, but a few people put weak, and it's not really weak. It's not spread out enough for it to be weak. You can tell a pretty straight line can go straight with these and be really close to all of those dots. So it's a fairly strong negative linear correlation. And you had to use an adjective to describe strong. You got a point off if you just put strong. Next section, most people got this one right as well. This is, I would say, when I say most, I was like 70 something percent people got it right. This is a true graph that I grabbed from this World Happiness Report that talks about the differences or um, the comparison between a global economy and happiness, or a lot of different things in happiness. And when it says interpret the graph, what are we learning from the graph? Well, each of these dots represents a different country. And what's happening? Well, the better the economy is in that country, the more happy the people are. I mean, that's ultimately what it's telling us, that the better the economy is doing, the more happy that people are in that country. It's not the other way around, though. A few people said the happier people are, the better the economy is. That's not true. So you got half credit if you put it that way. Remember, X always explains Y. Y always depends on X, not the other way around. This question, I was hoping it would be a gimme question. If you just look at the dots, can you tell me if it's mostly positive or mostly negative? Yeah, it's trending downwards, negative. It's super weak because this is super weak. It's really spread out, but you can kind of tell that it's got a downward trend, which means the R value has to be negative as well. That leaves either A or D in this particular case. A can't be the correct answer because this is a really strong negative correlation, meaning that the dots would be really, really close together in a line. The correct answer to this one is negative 0.2857. It might have been a different letter on your answer sheet, but this is because it is a negative trend, but it's super, super weak because the R value is really close to zero. This is the question that I thought I was surprised at how many people couldn't make this comparison. So here's a graph. It's a real graph comparing shoe size and your reading score. And it says, is it reasonable to conclude that does shoe size cause someone to have a higher reading score? No, not really. Shoe size doesn't cause it, but there's still a correlation. You can see the correlation there. Why do you think there would be a correlation here? How many of you got this question right? There's an explanation for it. What happens to your shoe size as you get older? It gets bigger. Well, what happens to your reading ability as you get older? It gets better. So obviously, the reason there's a correlation here is that as you get older, your shoe size gets bigger, but you're also probably reading better too. That's why. That's the explanation. I was hoping that you guys would be able to see. So you got 3 points if you said that it wasn't reasonable for that, and you actually wrote it out, and then you got full credit if you were able to tell me why. The next question, you didn't have to do any math. I gave you a table, but I already gave you the equation that goes with that table. All you had to do is tell me what kind of function this is written out right here. This is a logistic function. And according to the equation, about how tall will the plant grow? All you had to do is remember that the A value, which is the top of the logistic function, is the upper asymptote. This is what the graph is going to look like. And this asymptote, or this carrying capacity, is always going to be the A value. The A value is always the number on top. So this graph is going to only grow up to about 22.8 inches. So again, no math needed for this problem. Just needed to know what you were looking at. Next section. This question came directly from that 7.6 ed puzzle. It was a really short ed puzzle. It was 7 minutes about step functions, and more than half people missed this question. No, I'm sorry. About 40% of people missed this question because they didn't do the assignment. This is a step function for tornado scale in the U.S. I'm sure you guys have heard of like a F1, F2, F3, F4, F5 tornadoes. This one is asking what scale would a tornado be at 110 miles an hour? If you go up to 110, you see this first, it hits this dot, but what does an open dot mean? It doesn't, yeah, it's anything after or before. So it can't include that open dot, so I got to keep going. There is the closed dot on the EF2, so that's the correct answer. How many of you got that wrong? You got it right, right? Yeah. You got it wrong? And easy. It was supposed to be a gimme question. Well, that would be a super easy question. Next question. Again, I didn't have you type this into the calculator. I gave the equation already for you. It shows the temperature in Buenos Aires in Argentina throughout the year. This is a sine function, meaning that, of course, what's going to happen with temperature? In the summer, it's going to go up, and the winter is going to go down. Summer is going to go up, winter is going to go down. All right. On the according to the model, what is the average temperature? Well, average temperature is always going to be wherever the axis of symmetry is, right here in the middle. That axis of symmetry is always the D value. So the temperature, the average temperature is about 62 degrees. Okay? That is average temperature throughout the year. What is the amplitude? Amplitude is always the A value, which is the number up front. So again, you didn't have to do any math. You just need to know where to look, about 12.17 degrees. And what is the minimum temperature in Buenos Aires? Well, in order to find the minimum, which is right here, you need to take the axis symmetry or the average and subtract the amplitude. Remember, this is the amplitude right here. So we know we just got to take this number and subtract this number. Once we subtract those, you get about 50 degrees. So there is the 3 answers there. If you knew what you were looking at, this should have been pretty easy. Second to last question, another one. I gave you guys the stuff from Desmos to save you some time, so you only had to do one of these, which was the last question. This is let's take a look at it. This is a really strong, you can see it's all on a long line. So you're matching up the information here. There is a very strong positive exponential correlation. Exponential is it's curving upwards. We see right here these baseball players' salaries. Note that the baseball player average salaries is in thousands of dollars, and these numbers are years since 1984. Since it's exponential, the equation that we're going to pick is the exponential one, not the linear one. So all you have to do is pick the correct exponential one. Using this equation, a salary of a player in 1999 would be about, well, I need to use this equation and I need to plug in 15 for 1999 for X because this is 15 years after 1984. So you should subtract that to get 15. When you plug that in, you actually get this number 4,067, but this isn't thousands of dollars, so you kind of have to multiply it. You have to multiply it by 1,000 to get the correct answer here. Obviously, $4,067 doesn't make any sense for a salary of a baseball player. $4 million, that's a little bit more like it. This prediction is an example of extrapolation. Extrapolation because it is a prediction outside of our data. Okay, it's beyond all the data that we have. Last question. You need to use the Desmos calculator, put the data into the calculator, write the regression equation. It should tell you what the correct equation was if you want to try that again or if you didn't get it close. I had to correct some answers because if you didn't type it correctly, exactly right. Nearest tenth is 1 decimal place. So if you round it incorrectly, then I just took off a point. And then you had to plug in this number, 160, for Y because that is the Y value, and solve for X, which is the number of people. Some people did it the other way around. So I think the correct answer here was 56 or 57, one of those two, in order to get the answer right. If you need any help or questions on this, just let me know. Any questions on your test or the grading of your test? Good.